I'm not going to wake up for rest of the night and walk back by myself. And then she said,
What?
and then she said,
Brady said you want to
one spot.
You want to go, Brady?
She's like, wait, this is the
Anarchy. No, it wasn't Ben. It was Ben. Ben Nimo.
Oh, it was? I thought
What is this anarchy?
Oh, he's in my seat.
Why did you give it to him?
I'm 105.9 in English right now.
Too bad you can't borrow points.
I know, right? He's like, only you could borrow points.
Hey, Emily.
And I actually.
Is this your sister's phone? No?
Why?
Wait.
Oh, it's Grace's maybe. Because I was just looking at like the cover picture and she's in there, but so is Grace, so maybe it's Grace's.
I see a picture.
S-A, right?
Yeah.
That's not Sarah? Oh, easily mistaken.
What?
They're together. I see that now. So then it must be Grace's because she's the only one who's in that hour.
Sarah, guess your birthday they come to her house like 4 to 6 in the morning, giant box, and popped out by Sarah.
The hair and a ponytail and the glasses.
Yeah.
This is great. I have a 1200% all my assignments to make up right now.
Do you have a black shirt?
I don't.
Does anyone have a black shirt? Black shirt.
If you don't like it, I will take it.
Go ahead and take out your assignments.
So hot.
And again, I'm talking about you. You're front row, so I don't have to do it. We need to play now. I like that let's see if it's for us.
Alright. Number 12 is 1/2 or 0.5.
Is there a specific one you wanted? I have both. I was just curious. Like,
Fractions or decimals are fine. Either way. If they're fractions, I would like them to be reduced fractions. If you left them unreduced in this lesson, you don't need to mark off. But when we come around to the test, if you're going to give a fraction, reduce it down or just turn it into a decimal. So number 12, 1/2 or 0.5. Number 15, unreduced would be 8 out of 20. That can become 2/5, which is 0.4.
0.45 is that?
No, just 0.4. 0.45 is 9 out of 20. And it should have just been 8 out of 20. I will go half on that, actually. The reason why you thought there were 9 is you probably thought that 1 is a prime number, and 1 is not a prime number.
What were the 8?
There were 8 prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. But 1 is not a prime number. So it should have been 8 out of 20. If you had 9 out of 20, I'll go half.
You got 7 out of 20 because you forgot 2. It's the only even number that's 5.
Oh, I'm being very generous here. I will go half.
Wait, you will go half?
Yes.
For what?
For a completely wrong answer. Number 18 is 1 out of 52 or 0.0192. Number 21 is 1/2 or 0.5. Number 24 and 27, we needed 2 answers. It asked for both a theoretical and experimental. For number 24, theoretically, rolling a 6 should be 1 out of 6 times. 1/6 is 0.167 as a decimal. The experimental would be coming from the data in the chart 26 out of 120, which reduces to 13 out of 60, or as a decimal, 0.217. So we ended up getting a lot more sixes than we should have.
I had the answers in the wrong order.
That's okay. 27, rolling an even number, theoretically should be half. Experimentally was 61 out of 120, which is 0.508, or really close to a half. So that was about right. Number 30 is 0.0218. If you rounded a few places, that's fine. I don't mind. Number 33 is 0.545. Number 35 is 1 out of 26, or 0.0385. And 36 is 4 out of 26, which is 2 out of 13, or 0.154.
Can you repeat number 30, please?
30 is 0.0218.
Did you miss one of the parts in like 24, 27 half?
Mm-hmm.
You're gonna only about $5 in the quarter, right? I have a 105.
In my little jar.
We also said that English either was about it. Yeah.
I never stepped back.
I said history. And then you said math.
I never said English. What size is this?
Hey, I got a 100. So now I have one off three for this. But then I have to factor in the exam. Hopefully I do good on the
Happy birthday to you.
Again?
Happy birthday to you.
Yes.
No.
Happy birthday,
dear Eddie. Happy birthday to you.
Is it actually your birthday, or is it?
It's the 27th, isn't it?
Before we jump into the notes for today, just a heads up, we will complete our lessons on probability and take our test on probability next week on Tuesday. And then on Wednesday, we'll begin our next topic. When we begin that, you are going to need either a small spiral notebook. By small, I don't mean like small pages, but like it doesn't have to be really thick, you know, just like a one subject spiral notebook. Or a small 3-ring binder with paper in it, because you're going to be handing something in to me as like a collection at one point. So instead of individual daily assignments, it'll be coming in to me at one point, and you probably won't get it back the next day, since I'm going to get 70 of these or whatever turned in. I have to grade them all. So you need either just a small spiral notebook or a small 3-ring binder that you can give to me that you don't need back in any really quick time frame. So that means that it would be used just for this individual purpose and not also for Bible notes or something like that. So I'm letting you know this now, even though you won't need it until next Wednesday, just in case if you don't have any and you need to add it to the grocery list, that can happen over the weekend, and you'll have that ready for next week.
Would it be okay if it's the same one you're using for homework already?
Yeah, but then you have to take everything else out of this. You know, I want it to be just for this purpose.
I care homework out as a.
So, like in a spiral notebook. So as long as there's enough pages left. All right, let's begin with our lesson then. Today we're going to continue talking about probability, and today we're going to talk about the probability of compound events. We're going to be thinking about OR problems today. So we talked about OR as a probability word the other day, and what are we supposed to do with the word OR? Add. Okay, so we're going to be adding probabilities of things today. We're going to be saying, what is the probability of this happening or this happening? There are two different cases we need to think about. The first is where it is impossible that both of the things could happen. Okay? It is impossible to roll a 2 and roll a 3. Right? The second thing we need to think about is the option that both possibly could happen. So thinking about in a deck of cards, it is impossible to draw a heart and a club if I'm only drawing one card. Right? There's no cards that have both of those on them. But it is not impossible to draw a card that is both a king and a heart. Okay? So when we do these, we will need to consider the possibility of whether or not both things could happen at the same time. If it is impossible for two things to happen at the same time, we call those mutually exclusive. There's no way they can happen at the same time. They are exclusive of each other. If it's possible that they both happen, then they are not mutually exclusive. So for our first example, we're talking about drawing a card out of a deck. Once again, if you're not really comfortable with your deck of cards, there is a page in your packet that shows you what comes in a deck of cards. So we're drawing a card. This question says, what is the probability that it is an ace or a face card? In the notation of probability, we would say probability of ace, or means plus the probability of a face card. Okay, that's how we denote our probability P, and then in the parentheses what we're going for, and the word or means plus. So what we need to consider is it possible that both of these things could happen? So is it possible, I'm only drawing one card, that when I pull that one card out of the deck that it could have an ace on it and a face on it? No, because the aces don't have faces on them. Okay, there's no way that both of those things can happen. So then we can just add up these two individual probabilities. So how many aces are there? 4 out of the deck of 52. And how many face cards are there? 12. There are jacks, queens, and kings. And so 3 different types of face cards, 4 suits of those. So 12 face cards out of 52. Add them up, gives 16 out of 52, which we can reduce down to 4 out of 13. Answer should be given as reduced fractions or as decimals. Our second question, we're rolling one 6-sided die. What is the probability of rolling a multiple of 3 or a multiple of 5? So what is the probability of multiple of 3, or means plus, multiple of 5? Is it possible that I could roll the die and what shows up fits both of these criteria?
No.
No, the smallest number that is both a multiple of 3 and a multiple of 5 is what? 15, and that's not on my 6-sided die. So there's no way that both of these could happen. One could happen or the other one. So how many multiples of 3 are there? 2, 3, and 6. How many multiples of 5 are there?
1.
Just 5. So add that up, and that is 3 out of 6 as a reduced fraction, 1/2. Okay, so both of these are what we would call mutually exclusive events. It was impossible for both of them to happen. So then we can just add the individual probabilities. Our next question asks, back to a deck of cards, what is the probability that the card is a heart or a face card? Is it possible that the card that we draw, we're just drawing one, meets both of those criteria?
Yeah.
Yeah, there are some cards that have hearts and faces on them. So what we need to do is subtract out the probability that that will happen. The probability that it is a heart and a face card. Here's what's going on. So I have a deck of cards. And I have separated out the hearts and the face cards. So I have 12 face cards. I have 13 hearts. But I can't just add 12 plus 13. Because that would tell me that I have 25 cards in my hand right now. But I don't. Because these 3 cards have to swap groups. Okay? They're included in both the 12 face cards and the 13 hearts. I can't count them twice. Okay? So we cannot just add the 2 individuals because that would be counting this group of cards twice. And we don't want to do that. So we need to subtract out that possibility that it fits both criteria. So we have 13 hearts. We have 12 face cards. But we've got 3 of them that fit both of those groups. So that gives us 22 cards that work for what we need. Out of 52, which reduces to 11 out of 26. Another way we illustrate these problems often is with Venn diagrams. So I'm going to show both ways of thinking about it, just either the probability notation or the Venn diagram notation, because some people are going to be able to understand one way more than another way. So a Venn diagram, we've got our overlapping circles here. Our 2 criteria are either hearts or face cards. There are 13 hearts in the deck and 12 face cards in the deck. But there are 3 cards that have hearts and faces on them. So that means there are 10 cards that just have hearts on them. So that whole circle still totals 13. And there are 9 cards that just have faces on them. So that whole circle still values 12. Or means add. So if I add up all of these numbers, I get 22. Just like the other way of thinking about the problem. Okay? So what we're looking at is what is the possibility that the 2 groups overlap each other? And there's 3 cards that overlap those groups. Okay? The next question, we're thinking about rolling a die again. What is the probability of rolling a multiple of 3 or, so plus, a multiple of 2? Is it possible that what shows up on the die could be both a multiple of 3 and a multiple of 2?
Yes.
Yeah, so I need to subtract out that possibility of overlap. How many multiples of 3 could show up? 2. 3 or 6? How many multiples of 2 are there? 3. 2, 4, or 6. How many multiples of 2 and 3 are there?
1.
Just 1. 6 is a multiple of 2 and 3. So that means there's 4 out of 6 ways this could happen, or 2/3. Yeah, with our Venn diagram notation, whoops. With our Venn diagram notation, I would be thinking of multiples of 3 and multiples of 2. There are 2 multiples of 3, 3 multiples of 2, and 1 that fits both of those groups. So there's one number that's just a multiple of 3, and there's 2 numbers that are just multiples of 2, 2 and 4. Or means add, so we add up our possibilities to get 4 out of the 6 things that could happen when we roll our die. Questions? For the next card or the next problem, I'm just going to illustrate it with a Venn diagram because I think that makes the most sense here. Last year, a company paid overtime wages or hired temp help during 9 months. So keyword there is or, gives us 9. Or means adding. So when we add up stuff, we should get 9. Our categories here are overtime and temp help. Overtime wages were paid during 7 months. So overtime is 7. And temp help was hired during 4 months. Temp help is 4. Now, or is supposed to happen when we add. So when we add, we're supposed to get 9, but when I add these, what do I actually get? 11. What does that mean?
2 months overlap.
2 months overlapped. 2 months, the companies had to do both of these things. When I add, I'm supposed to get 9 because that's what they said the or is. But when I actually add, I get 11. So that means that 2 months, they must have really needed a lot of extra help and had to do both of these things. So that means during 5 months, they got by with just overtime. And during 2 months, they got by with just temp help. And altogether, that adds up to 9. Okay? So to find our overlap, we look at what it does add up to as opposed to what it's supposed to add up to. It actually adds up to 11. It's supposed to just add up to 9, so that difference of 11 and 9 must be our overlap. So our question says, at the end of the year, an auditor examines the accounting records and randomly selects 1 month to check the company's payroll. What is the probability the auditor will select a month in which the company paid overtime wages and hired temp help? So in how many months did they have to do overtime and temp help? 2. In 2 of the months, they had to do the and, the both. Okay, so and is that overlap space. Out of, be careful, how many months could the auditor have selected? 12. There are 12 months in the year. He might get lucky and choose a month that none of this stuff was happening, and that would be an easier audit for him if it was all just regular payroll stuff. He might get unlucky and end up choosing one of the months where all kinds of stuff was going on, and then he has a really big job on his hands. But he could have picked any of the 12 months of the year. The denominator always needs to be the total possible choices he had. Okay, he had 12 months to choose from. I always want to give it as a reduced fraction in our final answer or as a decimal.
So we don't need the 9 at all.
So we don't need the 9 at all. The 9 helped us find that overlap of 2. Like without being given that, we couldn't have found the overlap of 2. But we don't need it in the final answer. Okay, we have one more like this one. In a poll of high school juniors, 6 out of 15 took a French class, 11 out of 15 took a math class, and 14 out of 15 took French or math. So our categories here, we have French and we have math. 6 took French, 11 took math, 14 took French or math. Or is our addition. But when I actually add them up, I don't get 14. What do I get? 17, which means what?
3.
3 of them were taking both classes. Okay? Since it actually adds up to 17, but it's only supposed to add up to 14, that difference is how much must be in the overlap of both groups.
How did we get 14?
It tells us that 14 out of 15 took French or math. It just gives it as a word instead of as a numerical figure. So it's easy to overlook it. So that means that 3 were just taking French and 8 were just taking math, and 3 were taking both of those classes. What is the probability that a student took both French and math? Where are ands here? The 3. Okay. The overlap is our and. So 3 out of 15. Only 14 kids were taking these classes, but they actually asked 15 kids. So there's one kid who's taking like Spanish and science, okay? They're not taking these classes. But we still want our bottom always to be the total that we could have selected from. There were 15 kids in the group. Reduce the fraction down to give a final answer of 1/5. or as a decimal 0.2. The last thing we need to talk about is what is called the complement of an event. Our notation for this, we use a little apostrophe. So when you see a little apostrophe there, in math we read that as prime. So when you see an A with a little apostrophe, we say A prime. And in probability, this means the complement of an event. The complement is the probability of the opposite thing happening, okay? Or the probability of it not happening. You guys already know how to figure this out. If there's a 30% chance it's going to snow, what's the chance it's not going to snow? 70%. Okay, so we already know this. It's something we've done for a long time without really thinking about it. It's the opposite probability. Okay, so we find that by subtracting from 1 or subtracting from 100%. Sometimes it's easier to find this opposite probability because there's less things to figure out with that. So in our example here, we're looking at 2 6-sided die being tossed. It says there are 36 possible outcomes. The next page in your packet gives you a chart that shows you what all of those outcomes are. The reason why there are 36 outcomes is we say that rolling a 2 and a 1 is different than rolling a 1 and a 2. If you're rolling 2 white dice at the same time, you can't tell the difference between them. But if one of the dice are red and the other die is white, then rolling a 2 and a 1 would be different than a 1 and a 2. Okay? Or if we roll one die first and then the second die, we would be able to see those as different outcomes.
Does that really matter though? Because like if they just add up to the same number.
It does. If we're thinking about sums, then yeah, they're going to end up adding up to the same thing, but that's 2 individual ways that we could get that same sum. So we're going to consider out a possibility out of 36. You have this chart, so you can use it to refer to when you do your assignment. The first question that the problem asks you about this is, what is the probability that the sum is not 8, or I would say like 8 prime. That apostrophe we mean as the word not. Well, there's a lot of these that don't add up to 8. So I could go through and figure out how many don't add up to 8, but what might be easier is saying how many do add up to 8 and taking the opposite of that, or the complement of that. Okay? So, how many of these do add up to 8? Let's see, 2 plus 6, 3 plus 5, 4 plus 4, 5 plus 3, 6 plus 2. It's very handy that in this chart, when you're looking for sums, they will always happen on a diagonal. So that is a very convenient thing about the layout of this chart. So there are 5 ways we could get 8 out of 36 things that could happen. If I want to subtract these, I need a common denominator. So that means there are 31 out of 36 ways to not get 8. Okay. So if I'm playing a game and I lose if I get an 8, then I want to know what is the probability I'm not going to get an 8. So what's the probability I can win this time? And that would be a 31 out of 36. Okay. The second question it asks is, what is the probability that the sum is greater than or equal to 4? There's a lot of these that add up to greater than or equal to 4. So we could go through and figure out how many there are, but it might be quicker to think about how many don't meet that criteria. So what's the opposite of greater than or equal to 4? Less than 4. And there aren't very many of those. So if we wanted to add up to less than 4, adding up to 1 and 1 would work. 1 and 2 works, but the next one over, 1 and 3, that's too much now. 2 and 1 works, 2 and 2, that's too much, 3 and 1, that's too much. So there are only 3 ways to get a less than 4. Get our common denominator. So there are 33 ways to get 4 or more. Reduce down, 11 out of 12. So that complement notation, that prime notation, is when we're thinking about the opposite of something happening and we do 1 minus it.
No.
Our last problem here goes back to thinking about a deck of cards. Card A says, what is the probability the card is not a king? So I would say the probability of king prime. Okay, not a king. So I could do 1 minus the probability of it being a king. How many kings are there?
4.
Out of the 52. We get a common denominator. So there are 48 not kings, or 12 out of 13 when we reduce that down. He says, what is the probability that it is not an ace or jack? So I want probability of ace or jack prime. Okay, the prime is the word not. So I'm going to do 1 minus the probability that it is an ace or a jack. And when we use the word or, we need to be careful and think about, is there a possibility it could be meeting both of those criteria? Because then we need to subtract out that overlap. So is it possible when I draw my 1 card that it could be an ace and a jack? No. There aren't any cards that have an ace and a jack on them. So we don't have any overlap here. These are mutually exclusive. So how many aces or jacks are there in the deck? 8. There's 4 of each of them, and we can just add them together since there's no overlap. Get a common denominator. 44 out of 52, or 11 out of 13. Questions? I want to look at an example of the first type of homework problem you have, just to make sure that you understand the notation that's given on those types of problems. So in the first group of problems, there are 4 different pieces of information, and one of them will be left blank. So I'm doing one that is like the problems you're assigned, but not actually one of the problems you're assigned. Yeah. Okay, so for all of them, there will be these same 4 pieces of information, and one of them will be lacking. I would recommend doing these problems with a Venn diagram. It's not necessary. You can use kind of the formula way of thinking about it like we did in some of the homework problems. But for me, I'm just a very visual person, so I think Venn diagrams are a good way to illustrate what's happening here. If you're more of a formula person, then you can use the formulas. The probability of A is 0.6. The probability of B is 0.2. OR is what happens when we add everything. So our OR should be this addition, and that's what we're looking for in this problem. And is our overlap, which in this problem is 0.1. So in each of the problems, you're going to be given 3 pieces of information, and you kind of fill those in where they belong, and you'll be lacking one of the pieces of information. And then you can kind of solve through the puzzle to find out what you're missing. So if the overlap is 0.1, how much should be in just the A part of the circle? 0.5, so that the whole A circle is still 0.6. Okay, the whole circle has a value of 0.6, so since 0.1 is already covered, 0.5 must be the rest. How many is in just the B portion? 0.1. So when that adds up across the middle, I get 0.7, and that's our OR. Okay, so that's what this problem is looking for the answer, is that OR, or the adding. The question also asks, are these events mutually exclusive? How can we tell if they are mutually exclusive? If the and is 0. Okay? Mutually exclusive means it is impossible for both of them to happen. This one, both of them could happen. There's a 10% chance that both of them happen. Mutually exclusive means there is no way they can both happen. So mutually exclusive would be if that and portion is a 0. Okay, if the and portion is a 0, we call that mutually exclusive. So these are not mutually exclusive. Questions? Some of the problems will be given as decimals like this. Some are given as fractions. You may need to find a common denominator on those. And some of them are given as percents, but they can all be worked in the same manner. As a reminder, tomorrow is the last day of the quarter, so anything you're going to give me to make an effect to your grade needs to be done by tomorrow. Anything you can give me today would be greatly appreciated, so I don't have to grade late homework all weekend.
Really, how did that fare?
Yeah. If the events are mutually exclusive.
Because like this one, it's
Right, yeah. So, yes. We run into problems when we have like the of them.
and then when you're doing this formula,
Minus the and should equal the or. Yeah, so they should like solve the whole equation. This plus this minus this.
Yeah.
That works, yeah. I think the answer to the and question is it still works if you figure out some individual probability. So like on this one,
It's 12.92.
0.5.
5, 6, 7, 8, 9, 4.
That's it. Oh no.
18, 21, 24, 25, 26.
Yeah, 5.
What do you have in
Actually, no.
99.
Right, that would get the
Right.
18, 21, 27.
We have 5 electric credits
25,
tomorrow
26.
while I'm reading. If one of you emails us. And we have geometry. Do you have anything else to do tomorrow?
Wait.
I know it has something to do with the overlap because they can both Bible.
You're gonna have to
That's what's messing it up. As opposed to what we did the other day.
Reason's got amazing.
Separate events.
Who's phone is on? Where do you live?
I went to Richard Gosselin.
It's a hike. You're just looking good. It says right. We're really close to something. Right by that giant
Decided the prologue.
What?
It probably says the same thing.
Well, we took a test and we both
Yeah, we
got
took a test. We got a 96.
6 to 9.
in my other.
You know, I used to